Authentication and authorization are critical components of Kubernetes security. They ensure that only legitimate users and services can access the cluster and that they can only perform actions they are explicitly allowed to. Following is a detailed view of the authentication and authorization mechanisms in Kubernetes deployments. 1. Authentication in Kubernetes. Authentication is the process of verifying the identity of users, services, or applications attempting to access the Kubernetes cluster. Kubernetes supports multiple authentication mechanisms. Authentication mechanisms: static, token files. A file containing bearer tokens is provided to the API server. Each token is associated with a username and group. Limitations: tokens are long-lived and must be manually rotated, not scalable for large clusters. Use case: suitable for small, non-production environments. X.509 Client certificates. Users authenticate using client certificates signed by the cluster's certificate authority. Certificates include the username and group information in the common name and organization fields. Best practices: use short-lived certificates and automate rotation. Restrict access to the CA private key. Use case: commonly used for authenticating administrators and automated systems. Service account tokens. Kubernetes automatically creates service accounts and mounts their tokens into pods. These tokens are used by pods to authenticate to the API server. Best practices: avoid using the default service account. Create dedicated service accounts for each workload. Use case: authenticating applications running inside the cluster. OpenID Connect integrates Kubernetes with external identity providers. Example: Google, Azure Active Domain, Keycloak. Users authenticate with the identity provider and receive an ID token, which is used to authenticate to Kubernetes. Best practices: use OpenID Connect for human users in production environments. Configure role-based access control to map OpenID Connect claims to Kubernetes roles. Use case: enterprise environments with centralized identity management. Webhook token. Authentication: the API server calls an external webhook to validate tokens. The webhook returns the user's identity and group information. Use case: custom authentication systems or integration with enterprise identity providers. Bootstrap tokens, used for bootstrapping new nodes or joining new clusters. Tokens are short-lived and automatically expire. Use case: initial cluster setup or node provisioning. 2. Authorization in Kubernetes. Authorization determines whether an authenticated user or service has permission to perform a specific action. Kubernetes provides several authorization mechanisms. Authorization mechanisms: role-based access control, the most widely used authorization mechanism in Kubernetes, defines roles permissions and binds them to users' groups or service accounts. Key definitions: role defines permissions within a specific namespace. Cluster role defines permissions cluster-wide. Role binding binds a role to a user, group, or service account within a namespace. Cluster role binding binds a cluster role to a user, group, or service account cluster-wide. Best practices: follow the principle of least privilege. Regularly audit roles and bindings. Use tools like KubiiWALL to verify permissions. Use case: fine-grained access control for users and services. Attribute-based access control grants access based on attributes. Example: user, resource, action. Policies are defined in a static file and require API server restarts to update. Limitations: less flexible and harder to manage than role-based access control. Not recommended for production environments. Use case: legacy systems or simple access control requirements. Node authorization grants permissions to Kubernetes based on their node identity, ensures that Kubernetes can only access resources related to their node. Use case: authorizing Kubernetes to interact with the API server. Webhook authorization. The API server calls an external webhook to authorize requests. The webhook returns an allow/deny decision. Use case: custom authorization logic or integration with external policy engines. Always allow and always deny. Always allow allows all requests, not recommended for production. Always deny denies all requests, used for testing or emergencies. Use case: testing or debugging scenarios. 3. Best practices for authentication and authorization. Enable role-based access control. Always enable and configure role-based access control for production clusters. Avoid using the always allow authorization mode. Use strong authentication, prefer X.509 client certificates or OpenID Connect for human users. Use service accounts for applications running inside the cluster. Follow the principle of least privilege. Grant only the permissions necessary for each user or service. Regularly review and revoke unnecessary permissions. Secure service accounts. Avoid using the default service account. Disable auto-mounting of service account tokens when not needed. Enable audit logging. Log all authentication and authorization decisions. Monitor logs for suspicious activity. Use admission controllers. Use admission controllers like pod security policy deprecated in favor of pod security standards, or OPA gatekeeper to enforce security policies. Rotate credentials. Regularly. Rotate certificates, tokens, and keys periodically. Use short-lived credentials where possible. Integrate with external identity providers. Use OpenID Connect or webhook authentication for centralized identity management. Map external identities to Kubernetes roles using role-based access control. Tools for managing authentication and authorization, KubiiWALL. Check if a user or service account can perform a specific action. Role-based access control. Lookup, a tool to visualize role-based access control policies, roles, and bindings. Open Policy Agent Gatekeeper. Enforce custom policies using admission controllers. KubeBench. Check if the cluster complies with Kubernetes security best practices. Audit 2 ABAC. Automatically generate role-based access control policies based on audit logs. Conclusion. Authentication and authorization are foundational to securing Kubernetes clusters. By leveraging robust mechanisms like role-based access control, OpenID Connect, and service accounts, and following best practices, you can ensure that only authorized entities can access and interact with your cluster. Regularly auditing and updating your policies will help maintain a secure and compliant Kubernetes environment.